All right, let's continue with this section 5.1. And I already wrote a few examples. Really, we just want to start super easy, and then it's going to turn a little uglier, right, as we move on. Same as we did with the derivative. So what is the antiderivative of x to the power of fifth? Well, that's straightforward. And again, by the way, see how I'm writing integral dx? That's always part of your notation. The integral and the dx must always be there. So you don't have just an integral, right? It's just really part of the notation. I know it's annoying. We'll see in section 5.4 where this is coming from, but every single time I don't forget to write the dx behind my function. So basically, there is my function right here, right? X to the fifth. Okay. So look back, keep the formulas in front of you. I don't really have much space here. But what did the power rule for antiderivative say? It simply says you're going to increase the power by 1 and then divide by that power. That's it. So the antiderivative of x to the fifth is x to the 6 divided by that 6. And always don't forget to add any kind of constant. So let's just check this. What does it mean to check? Well, we know this is the derivative of this function, right? That's my original function. So in other words, what? If I take this function and I take its derivative, I'm supposed to get this. So what's the derivative of this function? Well, let's see, what do we get? Something divided by 1/6 is the same thing as 1/6, right? Multiplied by 1/6. So to divide by 6 means to multiply by 1/6. We've seen this several times in examples in the last chapter. So it's 1/6 times. What is the derivative of x to the 6? Is a 6. Bring down the 6. X to the fifth. Plus, what's the derivative of a constant when I don't have an x in it? Well, that's a 0. So 1/6 times 6 turns into a 1, yes? X to the fifth. So boom, there it is, right? That's the derivative. Okay, let's add on. Now, what did the rules say if I want to find the antiderivative of some number times a variable part? So we have a coefficient in there. What do we do with the coefficient? Well, that second rule I put there on that previous page says that you're going to keep that coefficient and then move on and take the antiderivative of the variable part. So the antiderivative of x to the 7th is x to the 1 more, which is 8, divided by that 8. Okay, so 3 times something over 8 is the same thing as 3/8, x to the 8th plus k. So here is your answer, okay? If you want to check again, what does it mean to check? Let's take the derivative of this and see what we get. So we keep the coefficient, yes, the 3/8 times. What's the derivative of x to the 8th? Is 8, x to the 7th, yes? Plus the derivative of any constant, that's a 0. So 3/8 times 8, the 8's go away, and I'm left with 3x to the 7th, right? So as you see. Now, we're not going to check every single time. I'm just showing you that this rule definitely works, so we can apply it. Good. Oh, what am I to do about this? This looks ugly. Well, I don't know. Maybe we should be doing, we just said that I can deal with fractions, right? With x's on the bottom. What am I to do with that? Well, what I'm going to do with that is the exact same thing we did when we learned how to find the derivatives of quotients, right? That we wanted to avoid. So we rewrote the x, something over x to the third as an x to the -3. And now I can use the power rule, right? So it's not a fraction anymore. It's an x to some kind of power. So what does the rule of antiderivative say? One more time. We keep the 4, yes, times the antiderivative of an x to some power. What do I do with this power? I'm supposed to increase it by 1. Yes, I'm writing it this way because it's negative numbers. So just want to make sure we get it right. Plus some kind of constant, yes? So that's a 4, one more time, times x to the, what is negative 3 plus 1 more? Well, that's a negative 2 divided by that same negative 2. Okay, and of course, sure enough, I can reduce the 4 and the negative 2, and that gives me a negative 2 x to the negative 2. And as we've been doing, so again, these reduce, yes. And as we've been doing all along, you have a negative number, or a negative exponent, I'm sorry, or negative number in the exponent. You make it back positive by taking the reciprocal. So that's your answer. Now, I went nice and slow. You could definitely have skipped some steps. And same as what we did with derivatives, right? The more practice you get, the faster all this becomes. You just have to get used to it for now, okay? All right. So I'm adding in to the terms here, and we're going to add on to those powers. So we have another rule that says if you have sums and differences, what you're going to do is you're going to take and go through and take the antiderivative of each one of those. Now, I don't want to be all annoying and say that's the antiderivative of 4x to the 30x minus the antiderivative of 9x squared dx plus the antiderivative of 8x dx. Fine, I am annoying and writing it all out. But basically what I'm saying is you're going to split this integral, like we did with the derivative, to each of the terms. Okay, so I'm going to go one by one. You don't need to split it. Just as I said, the more practice you get, the faster you'll become. So you just have to concentrate on going and taking the antiderivative term by term. So this one's going to be a 4 times. What do I do with this power of 3? I increase it by 1, and then I divide by that same power. Minus 9 times the antiderivative of x to the second is x to the third over 3, plus 8 times, this is an x to the power of 1, by the way, right? So that's an x to the power of 2, that's 1 more than 1, divided by that 2, minus, now there's a rule that said what? The antiderivative of a constant is a constant times x, because remember, if you take the derivative of 150x, what's the answer? 150, yes? So, and now, why didn't I write plus a constant, plus a constant, plus a constant, plus a constant every time? Because all those constants would have added to some other constant. So you don't have to put plus k, plus k, plus k. You just have to say, well, all of this could be added to 22, right? And the derivative will still turn into that. So you just put the plus k at the very end. And that accounts for all the whatever separate constants might have come all along. So sure enough, we're going to reduce all this, make it pretty. And there's your answer. Okay. And we're not going to check every time, but I'm really curious, what's the derivative of this? So what's the derivative of this function? I'm not even going to rewrite it. What's the derivative of this? 4x cubed, yes, minus 3 times this 3 is a 9x squared, plus 4 times 2 is 8x, minus the derivative of 150x is 150, and what a derivative of a constant goes to 0, right? So is this the problem that we had to begin with? Yes. Okay, so as you see, we definitely did a good job on this. All right, let's try this one more time, maybe this time faster. And again, I already wrote it out for you. So let's see. What would be the antiderivative of this? I'm just going to go faster. So we'll keep the coefficient and then times what? X to the, increase the power by 1 and then divide by it. Minus 12x to the 1 more than 5 is 6, divided by that 6. Plus 3x to the 1 more than 4 is 5, divided by 5. minus 2x to the 1 more than 1, yes, is 2 divided by 2, plus the antiderivative of 3 is 3 to the, again, remember, you have here an x to the 0, yes? So that's an x to the 1 divided by that 1, right? Or, of course, you know the rule, right? The antiderivative of a variable, of a constant, is that constant times x. So the challenge here will be to remember that you are increasing the right? When you take the derivative, you go down. When you take the antiderivative, you have to go up in power. So that's the one difference you're going to have to keep in your brain. And remember that you are now going backwards, okay? And I know you're going to make mistakes in the beginning because you'll want to keep taking derivatives because that's what we've been doing all along in these last 4 chapters. But you'll have to retrain your brain to, okay, this symbol means I'm going up. Okay, so that's going to be a 2x to the 7th, right? Reducing, minus a 2x to the 6th, plus this doesn't reduce, so you'll keep it as a 3/5, x to the 5th, minus, these reduce, x squared plus 3x plus k. Again, you're welcome to take the derivative of this and see if you get this answer back. Okay. All right, so let's go through some a little bit easier problems, but what we want to do now, again, it's just one thing. However, this one thing is now a square root, and what rule can I use when I'm dealing with square roots? Well, the same thing that we did when we had to take derivatives of square roots. We rewrote them into powers. Now, see how I'm still trying to find my antiderivative. So I'm not dropping the symbol. I'm just rewriting the inside of my function. I'm just rewriting the square root of x. I haven't found the antiderivative yet, so I'm still dealing with my function, yes? Now, to drop this symbol and to say I am now finding the antiderivatives, what do? I have to increase this power by 1 and divide by that same power. And now I'm dropping the antiderivative symbol because I used it to find the antiderivative. So let's fix this. What is 1/2 plus 1? Well, that's 3/2 divided by the same 3/2. Now, sure enough, we do not want to divide by a fraction. So to divide by a fraction means to multiply by its reciprocal. So there's your answer. Now, again, you're very welcome to check. What's wrong here? So when I check this and I'm taking the derivative of it, 2/3 times the derivative of this is I'm going to bring the 3/2 down. X to the 1 less than 3/2 is 1/2. So all this goes away. I'm left with the x to the 1/2, which is the square root of x. Yes, and of course that constant goes to 0. All right. Let's try another one. So same thing. To even deal with this, I'm going to have to mess with my inside function. So I'm going to mess with this by writing it as a power. Now 7 is what that was multiplied to over the cube root of x. How could I rewrite this as an exponent? It's an x to the what? Well, the fact that it was on the bottom meant I had a negative exponent. Cube root is a 1/3 exponent, yes? So I just rewrote 1 over the cube root of x as an x to the negative 1/3. Good. And now I'm ready to find this antiderivative. So we'll keep the 7, yes, times x to the, what do I do with this exponent? I'm supposed to increase it by 1 and then take that same exponent and divide by it. Okay, so that's a 7 times. Negative 1/3 plus 1 is positive 2/3. And the same thing, negative 1/3 plus 1 is positive 2/3. Now, that doesn't look pretty right here with dividing by a fraction. So to divide by a fraction means to multiply by its reciprocal. Okay. 7 times 3/2 is 21/2. Okay. And now, again, I challenge you to take the derivative of this and see if you get the 7 over the cube root of x once you have it nicely simplified. All right. So I have a few more problems for you. Maybe we'll just do a couple, and then we'll finish this off with a couple word problems. Okay, so one more. Here, I'll just do this problem down here at the bottom first, just because it's something that we just dealt with. So here it is. What am I to do with this problem? Well, I am to rewrite it first. Okay, so that's going to be an integral of 1/3. I'll keep it as my coefficient, right? That's what that x is multiplied to, 1/3, right? Okay, this is an x2. What kind of an exponent do I have? Again, remember it's going to be a negative because it came from a denominator. And then 4/5, because you always divide. This is the fraction, the denominator of the fraction, and that's the numerator. So that's a 4 divided by 5, and negative because it came from the bottom, plus 2 times. How do I rewrite this? Now, this was a numerator number, so it's not going to have a negative exponent. We'll keep it positive, and that positive exponent is 7/3, right? 7 divided by 3. Okay, so I just rewrote my function. I'm not dropping these symbols because I haven't used them yet. What do these symbols mean? These symbols here mean to find the antiderivative. So in other words, increase your powers by 1. That's the rule. So the rule says keep the 1/3 coefficient times x to the, what do I do with this exponent? I'm supposed to add 1 to it. And then divide by that same exact number, plus 2 x to the, again, add 1 to this, and then divide by that same exponent, and of course, plus the constant k. Okay, so fixing this, and I'm going to be running out of space a little bit here. That's a 1/3 x to the what? Negative 4/5 plus 1 is a positive 1/5 divided by 1/5. Plus 2 x to the 7/3 plus 1. 1, remember, is 3/3. So that's 10/3 divided by 10/3. And then plus k. So what else we need to do here is we need to make all this a lot prettier, right? So combine these coefficients, yes? So one more time, to divide by a fraction means to multiply by its reciprocal. So dividing by 1/5 means to multiply by 5/1. Same thing here, to divide by 10/3 means to multiply by 3/10. So combining these coefficients here, and again, you could put in your calculator. You can ask your calculator, what is 1/3 divided by 1/5? And then the calculator right away, hopefully, will get you 5/3 for an answer. X to the 1/5 plus 2 times 3/10. That's going to be reduced to a 3/5. X to the 10/3 plus k. Now, one other thing you could do is rewrite the x to the 1/5 as a 5th root of x. And this is a cube root of x to the 10th, but just leave it at that. So I have a few more examples for you. We'll continue that in our third video for this section.